This is a short video that deals with this very particular acceleration, and that's going to be free fall. If we drop an object, an interesting thing happens. This is a little snapshot, and it's showing where the object is after each second. So after 1 second, it would have fallen this distance, 2 seconds, 3 seconds, and so on. So over on the left, you can see we have position time graphs, velocity time graphs, and acceleration time graphs. And you can see that we've got a negative slope, and that's because gravity acts down, which is going to be considered a negative acceleration. All right, so let's do a couple calculations. And using our equation of motion, let's use this equation first. We've got our v final equals our initial velocity plus this acceleration is so important we give it its own letter and we call it g. So the acceleration due to gravity we're going to call g. A lot of times we'll ask you to use 10 meters per second squared, but the actual value of the acceleration due to gravity is actually 9.8. But in this case, we're going to have an object that's dropped from above the surface of the earth, so it's above ground someplace. So my initial velocity is going to be 0. My final velocity then is going to simply be negative 10 meters per second squared, and it's negative because remember, gravity is always going to be acting down on you, times time. So my v final after 1 second, I would have a velocity of negative 10 meters per second, because if I put in 1 there, 1 times 10 is 10. The velocity at 2 seconds would be at negative 20 meters per second. Negative 10 times 2 is negative 20. The velocity at 3 seconds would be negative 30 meters per second, and so on. So look at what's happening to the velocity. It keeps getting bigger in magnitude by 10 meters per second every second, since that's the acceleration. All right, now let's go ahead and use this equation for the distance to see how far it's fallen. And remember, distance equals the initial velocity times time plus 1/2 the acceleration. But since we're dealing with free fall, we're going to put in g t squared. So it's the same equation we were using before. We're just now going to substitute in g. All right, so if I want to solve for the distance at 1 second, it's going to be 1/2 times 10 times 1 squared. Squared. And so 10 times a half is 5 times 1 squared is going to be 5 meters. So 10 times 1 squared times a half is going to be 5 meters. So after 1 second, it only falls 5 meters. Let's take a look at how far it falls after 2 seconds. So again, using 10 is a nice easy number to deal with, times 2 squared. This time I'm going to get 20 meters. So look at what happened here. The first second, it only fell 5 meters. But in 2 seconds, it's falling 20 meters. Okay, that's a big difference. All of a sudden, that distance, each successive second, is going to get bigger and bigger. The distance, let's take a look at it at 3 seconds. So if I take 1/2 times 10 times 3 squared, that's going to give me 45 meters. So look at what's happening to the distance each successive second. That's very different than what happened with the velocity. We're going to run the simulation and pay close attention to what's happening to the position, the velocity, and the time. Okay, take a look at the slope here. Initially, the tangent line would have a 0 velocity, but what's happening to the tangent as it goes along? It's getting steeper and steeper, but it's getting steeper and steeper in the negative direction. The actual magnitude of the velocity is getting bigger and bigger, but it's getting bigger in the negative direction, giving us a negative acceleration. Let's take a look at what happens with the ball projected upwards. Now pay close attention to what's happening in terms of on the way up and on the way down. The velocity and the distance on the way up is behaving the same as it is on the way down because gravity is acting the same no matter what, whether you throw a ball up or you drop it from the top of a building. Gravity is always going to be 10 meters per second squared directed down. All right, take a look at these problems. Remember, use 10 for gravity, and we'll see you next time.